Welcome to Aryabhat Center for Theoretical Physics. This is another video on the lecture say linear algebra, and in this video we are going to learn about located vectors and hyperplanes. First of all, let us consider there is a vector space Rn, and in the vector space there is a pair of points let us say A and B, and we have A I, B I. Then we can say that we can draw a line segment from A to B, and this will become AB equal to B minus AI, or B1 minus A1, B2 minus A2, dot 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 up to nth term, and this we can say this is U. So this is A, this is B, and from A to B, A is AI, B is BI. So it is simply BI minus AI. This is the line segment U, and all these are in the vector space Rn, and this A and B, these 2 points are the end point of the line segment U. And there is also a concept called hyperplanes. Hyperplanes set of point x1, x2, dot dot xn, which satisfy the equation ax1 bx2 dot 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 xn equal to 0. So if x1, x2, all these points satisfy this linear equation, then we can say that it is a hyperplane. All these points are on the hyperplane, and this equation, these points satisfy this equation. And U is U, we can also design a set which is A, B to C. All these are non-zero points, or all these are non-zero coefficient, not points, coefficient A, B, and all these are coefficient. And this is the definition of hyperplanes. If there is a point x1, x2, dot dot, and if that point satisfy this linear equation, then that all these points form a hyperplane. And so this is the definition of hyperplane, and this is the definition of line segment from 2 points A to B. So hyperplane and located, this is the hyperplane, definition of hyperplane and located vector. And in the next video we will explore more on this subject.